Hello, my name is Jedediah, and this is my project for computer science. My problem statement is shear stress due to torsion in a solid shaft. And my problem states there's a solid shaft of diameter D, length L is subjected to a torque T, given the diameter 20 millimeters, 0.5, length 0.50 meters. Torque 0.150 kilonewtons, shear modulus 80 gigapascals, and we are asked to find the polar moment of inertia J for the solid shaft, the maximum shear stress Tmax produced by the torque, the angle of twist over length in radians and degrees. The basic training purpose of this project includes variable and value assignment, input, float, arithmetic operators, print, and f-string. The first part of this project is the input section, where the users have to enter the diameter, length, torque, and shear modulus as a float value. Here we have D float input diameter in meters, L equal float input length in meters, T float input torque in kilonewtons, G float input shear modulus in gigapascals. For the second part, we have the unit conversion, which converts all the inputs into standard SI units. We have to convert the diameters from millimeters to meters, the diameter divided by 1000, the torque from kilonewtons meters to newton meters, the torque times 1000, and converts, and then the shear modulus from gigapascals, GPa to pascals, G times 1 times 10 to the 9th power. Here we have the mathematical processing, where the user applies the mechanics of materials formula. To find the polar moment of inertia J for a solid circular shaft, we use pi times d, which is the diameter raised to the power 4 over 32. To find the radius c, the radius is half the diameter. So to find the radius, we use the diameter divided by 2. To find the maximum shear stress Tmax, using the torsion formula, Tmax equals T, which is the torque, times C, which is the radius, or divided by J, which is the polar moment of inertia. To find the angle of twist using the angle of twist formula, it is equal to T, which is the torque, times length L, divided by G, the shear modulus, times J, which is the polar moment of inertia. Here we have the calculations where we further calculate the angle of twist in both radians and degrees and print the results. 1. We recalculate the polar moment of inertia, m to the 4th power, which will be the same as J. 2. Print the raw value of J, the polar moment of inertia. 3. We calculate the angle of twist in radians. 4. Print the raw value of phi underscore rad. 5. Convert the angle of twist from radians to degrees. 6. Print the raw value of phi underscore deg. Here the print function is used to display the output. You will print the calculated angle of twist, often presented as negative, to denote the twist direction. See the example below where the user will use f-strings, which allows the user to combine the text and variables inside one print statement. And the next step, will use the point to e format, which allows a number to be shown in two decimal places in the exponential form, and point to f to give only 2 digits after the decimal point. And the final will be the output results,